Well, this is the agenda today. We will start with an introduction to OAV as we know it in the GÉANT project, Orchestration, Automation, and Virtualization, to avoid saying the three words every time we say OAV, but you can tell whatever you want. It's automation or orchestration. Susanne and I will have this joint presentation. And after that, we will have several use cases from GÉANT, from NRENs, from institutions around the globe, from Internet to ESNET, and from projects like CENS, to see how each one of these entities has dealt with automation, and to see how different views or different tools can be used for the automation of your tasks. After that, and this is a very important part of the BoF, that's why this is a BoF, we have an open discussion where we would like to see what you think is the next to do for us. What are the next steps for the project? Is this task we are doing useful? Do you think we should do more of something? And this would be the last open discussion. And with that, I think we can start. I stop sharing and I give the floor to Susanne to start working on, or to start talking about OAV in GÉANT.
Thank you very much, Maria Isabel. Let me share the screen. Okay, you guys should be able to see this. Okay,
yes, we are.
So let me start then. Thank you. And also a very warm welcome to all of you from my side. I know it's not the same time zone for all of you, and it may be very difficult to attend the session. So thank you for joining. Let me first start out with the work that we did at the beginning of the work on OAV in GÉANT. We started out with a survey in 2019 because we wanted to find out the current state of the art, so to speak, with the different NRENs that we have in Europe. Almost, I think it's over 40 different NRENs in GÉANT. And so we conducted the surveys to see where everybody stands. And we had 5 major areas in the survey, which you can see here. We asked about existing network and services platforms that NRENs use. We asked about the current OAV use cases and services they have. And of course, we wanted to know if they had any particular challenges that they are facing, or also what priorities they see for themselves at the moment, but also looking into the future in the next couple of years. What do they expect? What steps do they want to take next and tackle next? And of course, we wanted to know how we as a project could help in the GÉANT community. The outcome was that everybody wanted to have knowledge exchange and expertise. There was a strong need expressed also for collaboration. But what we could clearly see from the answers is that the different NRENs also were at the whole spectrum, basically. There were NRENs that are high experts and very well skilled in this area. And then there are NRENs that said, okay, we know there's a need to do it and we have started some work, but we lack developers and we are just so overrun with basic daily operations, we can't get to it. And then, of course, there was the other end of the spectrum of NRENs who said, we are interested and we just started reading about it and we are total beginners, but we need more information and maybe tutorials and things. And it was also evident from the answers that we speak different languages when it comes to the terms. Not everybody understood the same terms in this area the way we use them. So there was a clear need for a terminology baseline. And what also came out at the survey was that NRENs do not really want to have one architecture that they need to adopt, but they want to have, they're more looking for a blueprint or some guidelines, some reference of how they could continue their work and still maybe ensure that they move along the same guidelines with others, so that in the end, in the future, this could also work on a multi-domain basis. And of course, everybody said they're willing to share experiences and also learn from each other. So based on the survey and the outcomes, we then came up with a number of focus groups, and we wanted to take some deep dives in these areas. Of course, we started OAV training and a public wiki, where you will see the link later, where we have all our materials and all the work that we did. One of the focus groups was also DTN and Campus Network as a Service as a use case. And we started a focus group on terminology and a focus group on architecture. For terminology, as I said, there was a clear need for a common ground of understanding. So what we did is we tried to identify a list of relevant terms that often come up in the OAV discussions and materials. And we just made a list and tried to look for standard-based definitions as much as we could find, but there were terms where we couldn't find a definition. So we tried to define the terms ourselves. First within the focus group, and then also within the task. In our task, we have about 16 different NRENs. So we were able to find pretty good consensus on the definitions we came up with. And we published a white paper on that terminology work we did. And a couple of months after that, we had an exchange with the GNA-G team and learned that they were actually looking into the same kind of issues. And we exchanged the document, they gave us some feedback, and we came up with an updated revised version 1.1, which you can also find on our wiki, which is now adopted by both of our teams. And you can, of course, see it also online directly. Then for the architecture focus group, we looked at a number of architectures that are popular in OAV. And we also tried to find what are the common characteristics they may have, what are common things that they all share, and what are things that we would put into an architecture blueprint if we could come up with a wish list and start from scratch. And one of the most basic fields was basically building blocks. The architecture blueprint should be modular so that it scales easy. It should have standardized interfaces, and then this way lead to easier collaboration. And the outcome of the survey and the workshop that we had clearly also stated that NRENs want to have something like the Vegas rule, meaning what happens in the NREN stays in the NREN. So collaboration with building blocks and functional blocks is great and open interfaces, but there often NRENs have these legacy tools. They have homegrown software and tools that they just cannot get rid of very easily because they may have some local constraints that other NRENs don't have. So they would like to keep their own tools and their own processing at first and be able to do that digital transition at their own pace. So the Vegas rule is very important. If you can do within your own organization whatever you need to do at your own pace, but still be able to collaborate and agree to a common blueprint, that's the way to go. And after studying the different architectures, what we found to fit best within that context was the TM Forum Open Digital Architecture. Because it's actually not an architecture, it's a reference architecture. It's an actual blueprint. It identifies these colorful blocks that you see here, these 5 blocks, that deal with engagement management, that deals with your user interface, your self-service portals. Then you have a block that handles all the party management you have, where you identify your customer types and partners and policies. And then you have a core commerce management block where you do all your commercial cataloging of services and products. And then you have the production block where you actually orchestrate the provisioning of the products that were ordered, and where you have your virtualization layer to the underlying hardware domains and technical domains that you have that other NRENs may not have. And then you have the intelligence management block for your analytics and your monitoring. And all these blocks, of course, have standardized interfaces and open APIs. You can read up on our work as far as architecture is concerned on the white paper we published last month. You can also find this on the wiki. And in order to show that indeed all these different NRENs from all these different areas and specific country constraints that they may have, to show that all these NRENs actually can be mapped to that reference, we started working with a number of NRENs and did these architecture mappings to ODA. And we started out with SURF, which is very much advanced, as you know, and mapped it to these functional blocks of ODA. This was published as a white paper. We also did the same thing for CYNET, which is a very different type of NREN, because it is the NREN of Cyprus, which is a small island. And as an island, they have different issues, but they were able to map their architecture and their work to the ODA reference. And our latest mapping is CARNET, the NREN of Croatia, and they also have a very different setting in their home, because they have a lot of schools they have to work with and automate the work and provisioning for the schools. They have over 700 islands, and some of those are very remote, and so they have also very specific country-specific constraints. But this is their mapping also to ODA, and all of these mappings were published as white papers that you can find. Currently, we're working with GÉANT, with HEAnet, GÉANT, PSNC, also for mappings, so that they can show how they do their mapping to this ODA architecture, reference architecture. And if you're interested and you would like to work with us, we would love to work with you and have you also as a very interesting example of how your architecture can be mapped to this reference. So please, if you're interested, contact us. This is the end of my part. Maria Isabel will now continue with the training focus group.
Thank you very much, Susanne. Can you see my screen?
Yes.
Yes, thank you. Well, as Susanne mentioned, we had several focus groups, and as knowledge was mentioned as a gap, we created a focus group on training to prepare a training. Even though there are many different places where you can find information about automation, about tools for automation, you can very easily get lost because there are many of them. And we wanted to do something more tailored to the NREN case, to the research and education institution, as the survey told us that there was a knowledge gap and many NRENs were not following the same pace as others. Many of them have not already started, so we wanted to push them to start. So do something that is useful for them and where they can, oops, I'm sorry, where they can find their own examples that are easy to understand for them because they are the same as they use in their homes, but from other NRENs. Sorry. So we keep this idea of having it from the research and education world and to the research and education world, from the community and for the community, so they could find themselves reflected in these use cases and even collaborate with us in the future if they had something relevant to share in the same training. We thought about the training as a phased approach with several phases and with several learning paths. And what we built was like a metro map. You can see it here, but it's also in our wiki page, and maybe you will see it easily there. You have like a metro map because there are different itineraries, different learning paths. You have this, what you see, it's blue here. It's like a green line or introductory line, where you see introduction to all the functional blocks in ODA, as Susanne mentioned, but also introduction to other things that are relevant for automation. For instance, introduction to automation, introduction to orchestration, just introductory learning units that maybe for an advanced research and education network that has already gone through all the path are not necessary, but for others may be very relevant. What we did here is this line. This line is almost finished for us. We have 11 learning units published, and we also have the white papers that Susanne has mentioned. We have 6 documents published in the squares in the stations of this metro map. The squares mean they are documents, and the rounded metro stations are videos or learning units in Moodle. We did this thanks to the help of the GLAD team, the E Academy. We have everything in Moodle. We have short videos. It are 5 minutes maximum videos where you can easily find something that you can do for the automation of your network. The trainers are also from the community. So if you want to follow one of these paths, you can do it at your own pace, and you can find someone from the community, even from your own NREN, that is explaining this, or being able to be rich from you. That's why we have here the list of the trainers. We have 18 trainers. This is a group of people from several NRENs and several institutions around Europe that have experience in OAB, and they are from network engineers to managers and developers and university professors. So all kinds of people. You can also collaborate if you want. If you find that there is something missing that you would like to share with the community, we can add a learning unit from your site, no problem at all. And thanks to all the trainers that have already done so. And these are people from the community that can also be reached. We have an open window to the trainers that can be reached every month via video conference. We have a time slot where you can connect to a video conference where we will be there, and we will be answering questions and accepting suggestions, of course, if there are. It's in our training portal. The link is here. And this is a way to start with automation if you have not already done so. But we will have not so introductory learning units as we are progressing in this training. This was to try to fulfill this knowledge gap. We also did the OAV video. The OAV video, if you were here at 2 o'clock, you have seen it already. It's the first video we have put today for when we started the BoF. And it's there also to be ready to show to the NRENs or to the institutions that we approach when we talk about automation. Another tool that we have that comes from another of our focus groups is the OAB Wiki. It's a knowledge sharing place, a global exchange place among the NRENs and the research and education institutions. You have here the training portal, but also the architectures, the terminology documents. We have the use cases, applied automation, and everything is in the same place. One of the sub places in this wiki, OAB Wiki, is the community portal. The community portal is where you find use cases of institutions that are working in OAB. If you want to have your own use case listed here and you don't see it right now, please reach out and we will include it too. It's important to have it updated so that all the people can see it's something live. Then we have use cases in this same community portal. For instance, campus network management as a service is a clear use case of automation, because if you want to scale up, you need to have automation in your network if you're offering campus network management services. And of course, there are different use cases in all around Europe. There are many NRENs that are offering campus network management services, but each one of them is using it in a different way. But there is interest. So as there is interest to share this information, we have also done a kind of a communication work. We have a Slack channel for CNES. We have a mailing list for discussion. And more than that, we have community events. We have had info shares. We have included several campus network management as a service presentations in meetings like CNOC meetings and NEMO meetings. And we have this community portal that I mentioned. Beyond this technical stuff, we had also a service definition document that can help the NRENs that want to offer campus network management services to start with it. And another use case for automation, in this case, was DTN, data transfer nodes. We know that there are institutions, NRENs, that have very big data transfer nodes with very big links, 100 gigabit links, but there are also long tail scientists that need to do that, and maybe they are not so skilled. So we try to give them some guidelines for tuning DTN parameters and also to put them as a container infrastructure with Docker. We did a Dockerized example for DTN and also to automate the creation of these data transfer nodes. And there is a wiki that we also have in the GÉANT wiki about all this stuff about DTN, how we did some testbed services, some tests in the GTS, in the GÉANT testbed service, up to 10 gigabit per second. Finally, we created a pamphlet that is delivered to the NRENs when we approach them for collaboration, and where we speak how to transition, or where we present how to transition from the traditional OSS, BSS via a digital platform to an interoperable community, with the idea of having on-demand provisioning of multi-domain services in the future. And where we also talk about these architecture building blocks and open APIs that can be useful to go to automation. This pamphlet has the visual part. This is what I show now. And there's also the text part with more information. And it's also in the wiki and in the GÉANT page. With this, I stop here. I stop sharing my screen too. And now it's time for the use cases, in the NRENs. And I think we were going to start. We have changed a little bit the agenda to make a space for Mike to start, because he has an important meeting after that. So Mike, whenever you want, the floor is yours. Mike from Internet 2, Mike Simpson, is going to explain what they have done in Internet 2 for automation.
Oh, thank you very much. Yeah, and thank you for adjusting the schedule. I'm sorry about that last minute notice.
No problem.
So hopefully you're looking at my opening slide now. My name is Mike Simpson. I'm the Director of Infrastructure Systems and Software at Internet 2. That's a fairly new team, about a year old, that was established inside the Network Services Division at Internet 2. And I'm going to just talk very quickly about the automation and orchestration pieces of our next generation infrastructure, or NGI initiative, that's been running. So the NGI is our next network, is the easy way to say it. It's a complete refresh of all the layers of Internet 2's network. So optical packet, security functions are being revamped. We're adding a secure management network. Software functions are getting a lot of focus, so a lot of work towards automation and orchestration. And we're also changing the business models, or the way the nomenclature and the way we deliver our services is going to alter as well. So really a ground up rebuild of everything we do in network services. I want to focus just a little bit on the software architecture that we've started to build out. And I drew the diagram like a stack, top to or bottom to top, but you really should think of it like an onion from the inside out, so from the core out. And at the core of the onion, in the middle, at the bottom of the diagram, is the physical infrastructure, the routers and firewalls and switches and things like that. That's already in place. That was deployed by the end of March of this year. We're still doing some small remediations at various sites, but substantially we're complete. We have about 50 points of presence now up and running. Above that, there's two vendor products that are the next layer out of the onion. And that's Sienna MCP, Manage, Control, and Plan, which we're using to control all of our optical configuration. All of the new optical gear is managed through Sienna MCP at this point. That's up and running and in production. The other half of that vendor product core is Cisco NSO, the Network Services Orchestrator. So again, that controls packet level configuration on all of our Cisco gear. That's also up and running on a production basis, and it was used to deploy all of the backbone links and build out the backbone that we just did a couple months ago, month and a half ago. So that's up and running, being used by the network engineers to manage all of that configuration. The most important part of those two things, from my point of view, is that both those vendor products offer REST APIs. So they have native interfaces that the engineers are using currently, but they also have REST-conf-based APIs that we can address to do other interesting things. And that lets us build the next layer up where we're sort of in early prototyping now and starting to try to figure that out. So that what we call the unified API services layer gives us a number of advantages. It lets us encapsulate those vendor implementation details, so nobody from the outside world should ever need to know that it's MCP and NSO under the hood. We want to try and hide those details and present vendor neutral interfaces to the outside world. It also unifies the optical and the packet configurations so that if we want to design API calls or provisioning events that span the layers, again, that'll all happen on the backside of that unified API. From the front, you'll just see a provisioning event and you won't need to worry about what happened at the various layers unless you're really interested in it. And the last thing that unified service layer does is it gives us a place to tie into external services. So we're prototyping externalizing all of our single sign-on, session management, access control out to the in-common identity and access management framework that my colleagues in the Trust and Identity Division are running. And we're also, we've done some early prototyping tying sort of log aggregation. And I mean that in terms of microservices, audit logging, very fine-grained logging of what's going on in the system at all the levels, tying that into the Splunk cluster that our security team manages. And we'll find other places where there's things that we want to integrate with external services that, and that's a good place in the architecture to do that.
1 minute, Mike, sorry.
Thank you, I'm almost there. So then on top of that layer, the next step where we're just in requirements gathering now with our membership community and our network engineers, the consoles and tools that are then going to be consumers of that unified API to do interesting things, to implement workflows and high-level provisioning events. There's 2 early candidates that we've already kind of sussed out. We're most likely this fall, we're going to build out a service portfolio. So there's no one place in the Internet 2 URL space where you can go to see all of the services that you're currently consuming as a member from Internet 2. So we'd like to build that. And the other big piece is a routing portal. That's something the security team has asked for that'll let the membership more directly manage their peering interfaces where their networks touch Internet 2. Right now, all of that has to be done through service requests. It's very manual. So we'd like to make that more of a self-provisioning environment with the security team there helping out to make sure that things are done in a secure fashion. So that's kind of where we're at right now. I'll say just to quickly run through it, we're done with the optical and the packet installations. We've got our backbone up and running. We're doing what we call shim insertions. So we're bringing the new Cisco gear, the new Cisco switches and routers in line with traffic, but they're not doing anything. And then starting in August and September, we'll start migrating services over from the current Juniper-based network to the Cisco network. And then in the fall, we have to decommission everything so we can stop paying all the colo charges. And that's kind of where we're at now. If you have any questions or clarifications, I know that was a lot very quickly, please feel free to contact me at the email address that's on that slide. I love to talk about this stuff. I'm happy to answer any questions anybody has. And thank you very much for giving me time to come and present at this.
Thank you very much to you for your presentations and thanks for being so quick. We will take questions at the end if you don't mind it, so we can keep the schedule a little bit. I don't know if Mike will be here at the end, but if not, we can send him the questions we have. Thank you, Mike.
I actually have to sign off, so just send me any questions you've got, please.
Yes, thank you, Mike. Our next speaker is Roman Lapach from PSNC, who is going to explain the service provider architecture. Roman, whenever you want.
Yes, hi. My name is Roman Lapach from PSNC. Today I will describe shortly the service provider architecture and its implementation that we have made in the GÉANT project. So SPA is a modular architecture to guide the designers and developers to build a next generation digital platform, service management platform addressing new businesses and technology requirements. Requirements for the architecture. So the architecture should be flexible, to support the digital transformation, to be able to quickly, easily add new services. Unified approach to all services, another requirement, lightweight modular solution instead of monolithic approach, and open and interoperable So I'm thinking here about interfaces, open interfaces for communication between architecture components and integration with external systems. Architectural choices. So Lego type of service architecture. So simple components should allow to create complex services, manage the life cycle of all network services, use automation wherever possible, but semi-automation should be also possible. Orchestration for complex workflows, processes, common information model to represent different kinds of resources and services. The last but not least, we decided to use TM forum standards. Okay, so we in the first step we defined the architecture, but the next step was to implement it. So we have implemented components as a simple small microservices with REST APIs, the TMF open APIs. Some elements have been developed from scratch, but for some components we have used well-known open source tools, like, for example, for CRM components we have used Suite CRM. For service order management we have used OTRS. Okay, components, SPA components. As a front-end components, we have self-service portal and command line simple client application. For the management of the processes, we have service orchestrator. Another component is a service catalog to store information about available services. We've got CRM to store information about clients, order management to keep information about service orders. We've got service inventory and resource inventory to manage information about service instances and resources. We've got service activation component to integrate with external system to manage network infrastructure. And the last component here on the picture is service testing to run regular tests and on-demand tests. I mentioned about open APIs, so we can see here that each our component has such API.
1 minute, Roman, sorry.
Yes, we use TMF open APIs, just a small subset. TMF provides a lot of APIs, but we use only what we need in an SPA. Right now, SPA is used to manage the GÉANT connectivity service, GCS, which is operational service in the GÉANT infrastructure to create end-to-end links in the GÉANT network. We've been preparing SPA for new two services, GÉANT IP and MDVPN. The Polish NREN is testing the use of SPA inventory, one of our components, to store and manage the resources, information about resources in our national network, Pioneer. And soon we will offer Docker images for those who are interested to know how SPA works with some default settings. So people will be able to play with it, to test it, also in NMAS environment. So I mentioned about GCS production service. This is what you can see here on the left. SPA platform integrated with OpenNSA application that is responsible to create links in the GÉANT operational infrastructure. On the right side, you see a screenshot of the portal with 2 active links created via the portal. Okay, thank you. Much more information you can find on the webpage. General information about SPA, but also some demos. So I believe it's something very interesting. So thank you very much.
Thank you very much, Roman. Thank you. next speaker. We're going quickly, but then we will have time at the end. Our next speaker is Donald Cunningham from HEAnet. Donald.
And once you hit the unmute button, everything gets better. Good afternoon, everyone. My name is Donald Cunningham. I'm a technical architect in HEAnet in the Innovation, Research, Development and Evil Planning team. About HEAnet, we were founded in 1983 by some of our client members. We cover all levels of education, schools, primary and secondaries from about age 5 to age 19, and also third level universities and colleges. But we also cover a lot of smaller organizations, everything from the National Cancer Registry to the Central Applications Office for Unities and the Royal Irish Academy of Music. We normally work directly with the IT staff in an institution, but sometimes our services reach all the way down to the end users as well. From a systems point of view, we mostly use Puppet to orchestrate several hundred virtual machines, using a mix of the modules that come with Puppet, but also some modules that we've written ourselves or have adapted to work better for our needs. We're starting to do more and more with cloud, and as part of that, we're skilling up on Terraform from HashiCorp, which we find quite useful. We're not necessarily cloud first, because we do a cost-benefit analysis to try and work out if a service is going to be more effective to run in the cloud or to run it in-house. We use CSUC as our IPAM. It has an API which we abuse horribly, and we use it to provision DNS on the network as well. On the network side of the house, we are big fans of Ansible. Our main wide area network is built out of Juniper routers, MXs, 240s, 480s, 960s, and also ACX routers, the smaller 2200s and the medium-sized 5000s. We also have a data center network, which is built using Arista switches in a leaf and spine configuration. As part of the tender, when we moved from our old Cisco network to our newer Juniper network, people who applied to the tender and responded to it were asked to provide Ansible code, and we're still using that to this very day. The leaf and spine network in the data center is 100% managed using Ansible. Operational changes are via Ansible, and when you're first configuring a device, we use Ansible to generate that config. To build services on the Juniper network, we use CSD, which is Connectivity Services Director. It's a component of the Junos space system. We use it to build all our circuits. It's our single source of truth, effectively, for all of our Juniper equipment. It backs up all of our configuration as well, which we find very useful. At the moment, we're actually working on giving OpenNSA the ability to tie into CSD to be able to build and break circuits. That's something we're working on right now. We also use Google's Caperca framework for ACL generation. You feed it generic high-level ACLs, and it'll spit them out in Juniper, Cisco, Extreme, Palo Alto, whatever you want. We have it tied into our in-house GitLab instance, which is doing CI/CD, and that catches more typos than you can imagine. From the automation point of view, we have an in-house written product called Sheba, the Space HEAnet Integrated Broker Application. And yes, I had to practice that, which takes in information from CSUC and from CSD via Junos Space, and then uses this to provision Cacti for graphing, Ichinga for monitoring, Bind9 for DNS. It's always scanning address ranges so that it automatically picks up new devices so that they can be added into the systems. On the virtualization side of things, we've used for many years VMware ESXi hosts running on Dell hardware. We've recently refreshed this, and as part of the refresh, there is NFV capability, which we're very much looking forward to seeing what that can do for us. And 1 minute. And just as a note, if you look at the picture here, all of those lovely purple lights are Dell servers. Those 2 and a bit racks now fit in the new system in about that much in the rack, because time moves on. Thank you very much indeed. If you have any questions, drop me a note. This is my email. And thank you for listening.
Thank you very much, Donald. Thank you for sticking to the time too. Our next speaker is Wouter Huisman, and please forgive me if I don't pronounce your name correctly, from SURF. Wouter, whenever you want.
Yes. So yeah, my name is Wouter Huisman indeed. I have a presentation on our orchestration solution and actually an update of our achievements last year. Is it in presentation mode?
We can see the, yes, now it is fine.
Okay, cool. So I've got a couple of items to discuss. First of all, the workflow orchestrator, the open sourcing of that, our core component. Give you a glance of our supported products over time, and then discuss quickly on the firewall product, which we face some problems with, and then finally I would like to give you an idea of our self-service options in our customer network dashboard. So Peter Boer, my colleague, has also given a presentation last Monday, where he also mentioned the open sourcing of our orchestrator. So we've got an orchestrator core, and you see the orange blobs that are the open source components which we actually are using. And next to that, we have the SurfNet orchestrator component, which we interfaces nicely into each other. So we actually are using the open source software. Information is on this slide. You can download it from GitHub and find some information on the link. We are working on some example workflows to make it more easy to get a hold of how it works in our orchestrator. And ESNET is also working on the orchestrator, and probably in the near future also using the open sourced component instead of one of the branches. The orchestrator will have a document API, a product and subscription database, and also an API which we can use for our client, the orchestrator client, which will also be available soon on GitHub. If you're interested and to get a bit more details on this product, give me an email. We could organize a workshop of, for example, a day in which at the end of the day you have create your own workflow with the Hello World output. Probably something for after summertime. In our orchestrator, we typically define products to build our network services, and we can distinguish two types of services of products. We've got the customer-facing products and the infrastructure products. And of course, we had needed to start with the infrastructure products first. So how to define a node on the network, define core links in which the connectivity is realized, and on the left-hand side, the different customer-facing products. Over time, yes, as you can see, we started with ports and some service like path IP. We've added also last year the firewall, and finally this year we are working on also the peering products. So if we have completed that migration, all our configuration on our network is fully automated and orchestrated from the orchestrator. The firewall. Last year we built the firewall products, and the idea is that the firewall can be used in combination with the Surf Internet service. So the model is very easy. It's like this. But in the end, we realized that we need to create such a composed service.
1 minute, Wouter, sorry.
Oh, that's very quick. And the challenge is that, you have to combine those products. And finally, let me rush then. Because I think it turned out that the firewall was more feature-rich So we needed to redesign this product and make it more flexible. So we really redesigned this around more Lego block structure. I think the really nice thing I will also want to show is the network dashboard. It's our customer portal. We have restructured it in such a way that it's very modular and can be used for any product. So we've got a landing page with those tiles, product tiles, a list page with all the typical services you use. In this case, you see all the LightPath services. And then you can zoom in and get into the detail page for LightPath with all the configuration, port details, and also links to for example, planned work. So you can see how many events have happened in the network recently for this particular service. Even a calendar is there. And what we are now really working on is getting this, adding the self-service function. Yeah, the customer can use it. I really want to show you the demo because it's yeah, really making clear that our network dashboard is using the Orchestrator. Let me see if I can. There's still, yeah, nice. That it's you. Oh, let me quickly pause this. So on the right hand side is the dashboard. What you will see on the left hand side is our Orchestrator. So the network dashboard will do an API call to the Orchestrator after it has been after the step up function has authentication step up function has been done. And then we will change the parameter. So we go into the detail page. We do the step-up authentication. It's kind of mock-up, but it all works. Then we disable the DDoS filter. And what you can see instantaneously, a process is being kicked off in the Orchestrator. And after some time, it's completed and the setting has changed in the network dashboard. Well, I think that's the whole movie. Yeah. So that's all I want to show. Let me see. Do you still see my presentation, or?
Yes. Well, we see the YouTube, but I guess if you are, have you finished yet, Walter?
Yeah, I'm finished. Yeah.
Okay. Thank you very much for your presentation, even with the demo at the end. It's fast. Thank you. Our next speaker is Damir Rekvar from CARNET. Damir, you can share your screen. Thank you.
Okay, you can see my screen. Okay, I'm going to full screen. I'm not going to show you the demo because we don't have the time, but we are doing a lot about orchestration and everything else in CARNET. Just to remind what CARNET is doing, so we are connecting schools and non-higher academic faculties, university, everything. That's around more than 1 million users in academic and school users. We also connect all the health institutions in Croatia. Our current number is around 700. These are hospitals, public health sites, and etc., etc. And we also connect government sites. Each of these require different kind of services, different kind of SLAs, different kind of requests, and different kind of technical knowledge from the CARNET side, but mostly from the user side, because for example, in schools, you don't have a technician and everything else. So we try to mostly automate everything in the schools because of their lack of knowledge. On this slide, you can see basically how we started. We didn't start automation or orchestration because let's do it, because we did it because we need it. That's our basic goal. We started from the membership database. This was just basic, put the institution name in some kind of database, put some kind of contact name inside, but this application grew much more. So now you can see all the link details about institutions, lots of links to other portals and tools to get all the information from this institution. You also get some important documents about legal status of the institution and all the requests for the services the institution has. Based on that, we build our own NOC portal, which is mostly based on Xenos monitoring tool. But most important for us is also the NetFlow data. We collect all the NetFlow data and build orchestration and lots of automation around NetFlow, especially around protection against DDoS. For the schools, we did a lot of vendor integration because, for example, in schools, we have Cisco Meraki, and with via APIs, we are using it in our own application to automate some of the stuff and what's going on. Most of the stuff are also done for the reporting, which is very important thing for us, and also for some kind of preemptive thresholds, because we know how network should behave. And if network is not behaving like expected, we get an alert and all the details about it. We also did a lot of automation, not because we would like to do it, but because we need to do it, because we have a very lack of network engineers and a lot of work. So we are sending low-profile students and key personnel to do some maintenance work, but all the configuration is done via our automation tools. Thanks to work in GÉANT project and work package 6 task 2, we did this nice picture of our architecture. But bear in mind, when we started, we didn't have in mind that we're gonna do some standardized work. We did it, and we are happy that most of our stuff are actually in the right box. But who knows what's gonna happen in the future. Currently, we are now focused on the technical domain for the schools. Because we are building Wi-Fi services inside every schools, and also the passive and active network with switches and everything else. So we are investing a lot of orchestration, automation of these Wi-Fi services. But also we collect a lot of data, because for the next project we expect the old logs will be used for some kind of machine learning or AI in the future projects. So to make it simpler management of school LAN, or especially how to connect the errors automatically within the school LANs. So basically, this is all from me. You can find more data, and the file about CARNET architecture will be published as a white paper very soon on the GÉANT portal.
Thank you, Damir. And in fact, it's already there. It's already published. So
okay, I didn't know that.
it's published just this week. Yes, we have the link, and I will find it now and put it in the chat. Thank you, Damir. And the next speaker is Simone Spinelli from GÉANT. Simone.
Hi.
Hi,
Just
thank you.
a second. Can you see my slides?
Yes, we can.
Can you hear me? Okay, hi. So my name is Simone Spinelli. I'm a DevOps engineer in the network engineering team at GÉANT. I should specify GÉANT, the association. And in this short presentation, I'm going to tell you what we are working on in terms of orchestration, automation, and virtualization. I will focus only on the network, and I won't mention the many other interesting things that are happening inside the data center with VMs and containers and applications and stuff. So GÉANT network is mainly based on physical routers, Juniper MXs, 204, 480, and 960, and we use it as a PE routers. These nodes have a pretty big and complex configuration, and maintaining this configuration consistent and correct is our main challenge. Moreover, the new GN43N network is being deployed as we speak. And so we look at automation and orchestration to make nodes and services deployment more predictable and rapid. And so to make the work of our colleagues in implementation and in the NOC easier. In re-architecting the node deployment workflow, we strive for consistency, but we also wanted simplicity and flexibility. And for us, this means a clear definition of procedures and authoritative data sources, a better integration of change management and change tracking in the actual workflow. And in general, we would like to go faster and be safer at the same time when we deploy GN43N. Right now, we are doing this mainly using Git, and specifically GitLab for change management, version control, and CI/CD. We use Ansible for config management and automation in general, and Jenkins has some sort of web interface for scheduled jobs. So deploying a new node for us starts with applying a base config, which is a minimal system configuration that it's enough to bring the node online. And this is generated in GitLab as an artifact. So the operator compiles a simple YAML file with some basic information, submits a merge request. And if the checks are passed and the merge request is approved, the template gets compiled, and then the configuration is ready to be applied. Manually using netconf doesn't matter. When the node is online, it's ready to be added to the tools. And so, I mean, monitoring tools, configuration backup, configuration management, alerting, some custom scripts. And all of this is done via Git using the same mechanism I previously described. So a merge request, approval after passing basic checks, and then the CI will take care of adding the node to the tools. At this point, the node is ready to carry services, and we use Ansible playbooks to deploy customer-facing services like an NREN access point, so research and educational access, internet access, MDVPN, these kind of services. But we also use Ansible playbooks to deploy resource-facing services like backbone trunks or private peers. Again, Git is used to track and authorize changes and do the basic checks. To ensure that what we deploy stays consistent over time, every day Jenkins compiles entire stances of configuration and checks that the configuration deployed in the field still adhere to the intended golden configuration. In case of deviation, it alerts. So the change can be included in golden config, ignored because maybe it's a temporary change needed for troubleshooting, or can even be reverted. This golden config set of playbooks can also be used to deploy changes. And
1 minute, Simone.
Again, we use the same mechanism that we just described with the merge request, approval, and actual deployment. At this point in time, all the data we have is stored on Git. So we have common base configuration data and service-specific data. And while this is going to work in the near future, YAML files are not the best way to make information accessible and reusable for the rest of the company. So it's not good to build, it's not a good Lego block. So the next step for us is going to refine our service modeling. And to do this, we are looking at the inventory component of the SPA platform, the one that Roman talked about. And we want to use it as a service configuration database. It's based on TM forum standards. It provides the strictness and the flexibility necessary to model complex objects like network services. It's production ready because it's already in use in other contexts like GCS. And yeah, we think that the data contained in the inventory will be used by Ansible for the actual deployment, and will also be available to other components as a source of truth. Oh, that's it. Thank you. And if you have any question, I'm here in the Q&A, and you can write me at the address in the first slide.
Thank you, Simone. Thank you very much. Our next speaker is John Macaulay from ESNET. John, you can share your screen.
Got to unmute in order to talk. That was a safety tip. Okay, so everybody can see the slides? Yes?
Yes.
Okay, perfect, thanks. Hopefully we've cut this down from 10 minutes to 5 minutes. Let's go. All right, so ESNET is a complete rebuild of our network from the bottom up. New optical line system, new multi-vendor transponders, core and edge routers, compute on the edge, and our highly programmable data plane, which consists of Mellanox cards in the shells. On the right-hand side here, you see the major functional blocks of a management solution. I'm going to focus on the provisioning and workflow automation. In the past, our network has been managed by CLI, manual provisioning, set of homegrown scripts, Rancid and Ansible, but we did have automated provisioning of our L2 services through Oscars. So we've done automated provisioning before, and we've done, with Ansible and that, we did get some coverage. But our main goal with ESNet 6 is to move all our customer-driven services to a model-driven automation platform. Okay, so as part of the ESNet 6 solution, we're pulling together a number of our components. So if I can just run down the colors and what they mean. So blue boxes are components that we're actively developing on in ESNet 6. The gray boxes are basically components that we're purchasing off the shelf. Along the bottom, we've got our hardware in the network. On the right-hand side, we have our external systems, our support system, ServiceNow, Git for some revision control, our name server, IPAN server, and then we interface with external services like PairingDB and RedDB. Okay. Who are users of our solution? So basically, we have internal network engineering and planning team members. We support through NSI and Sense our external researchers. We have our My ESNet portal. It has some self-service capability, but our intention is to expand that much more than we do today, so that each customer can provision their own services where it makes sense. And then we have both internal and external NOC users. So through a set of APIs, we have a third-party NOC monitoring our optical line system, but then we also have our own NOC managing the rest of the network. Okay. We've taken a bit of a different approach. Everything, all the data as part of our services is considered network intent and modeled in our ESDB inventory system. So the first step anybody does before they provision a service in the network is they enter the service intent in ESDB. All right. Once the service intent is entered in ESDB, they can then go and use the SurfNet orchestration engine to do the activation phase within the network. And then the orchestrator, whereas ESDB has high-level service information, the orchestrator knows how to take that high-level service information, interface with the different systems to pull things together, for example, like the IPAM service in order to get IP address blocks assigned, and then pushes that service intent down to the Cisco NSO or Ansible tower, where they then instantiate that in the network. Now you're asking me, why do we have Cisco NSO and Ansible tower? Well, Ansible is going to continue to be used for our MVF compute functions and some of our supporting equipment. And at the moment, we're in a transition phase where we hope to get Cisco NSO completely across our packet network and shrink Ansible down just to the supporting equipment and compute role. So we hope to get there eventually. The key parts of the solution that we're developing is, as I said, ESDB for network intent, all-alarm planning. We've got historical network state, discovery service for current network state, which allows us to verify installation, allows us to make sure configuration is still consistent. We have cards disappearing all the time. We'll discover when a card's gone missing and update ESDB, as well as our topology service.
1 minute, John.
Okay. Use case, this is currently the big use case we have. We do a lot of bulk provisioning for ESNet 6. So they design it in spreadsheets, the planners bulk load that in ESDB, and then we have our engineers come in and start to instantiate that service. So they verify the plan state in ESDB. They instantiate the service using the orchestrator, where we get into our activation function. And as I discussed, the orchestrator goes off, secures additional resources, updates systems, applies intent to NSO, which then gets applied as network configuration. And then the orchestrator updates ESDB to say this service is now in the network and what its state is, so we can maintain referential integrity. And then lastly, We have a bunch of services and task workflows, so customer-facing services as well as infrastructure. Everybody's talked about these. Ours are very similar. Physical connectivity, that's ports to sites. We do a lot of configuration around that and set up naming. We have service edge, so internal ports to like per sonar service, those types of things. And we've got our infrastructure, node enrollment, base configuration, backbone link, digital SNC. So although we're not orchestrating the setup of a wavelength, we are doing the digital cross connects on the transponders. And then the magical high touch precision telemetry, which I won't go into. We have some security workflows. So black hole routing allow customers to control black hole routing of their prefixes, as well as monitor their prefixes. And then the standard L2, L3 VPN IP services, internet transit. And then we have some task-based workflows, circuit migration, customer and peer migrations. Lastly, the key here is, and those that are using NSO, orchestrated service is not an NSO service. You know, you're building a higher level services using the orchestrator, consuming smaller base services within the NSO platform. And that's been really going through the design. We build the NSO services as well, so that there are some that we aren't orchestrating and we give access to the network engineering to do through CLI or through their own scripts. So we're trying to get the best of both worlds. Our engineers really like to write their own scripts. So they can do that either through NSO or off the top of the orchestrator. That's it.
Thank you. Thank you very much, John. It was shorter. Thank you. And last speaker today is Tom Lindman from the SENSE project, also from ESNET as John. Tom, are you here? Yeah.
Yes. Hello, everyone.
Hello. Thank you.
Can everyone see the slides okay?
We see the slides, but with all the small slides, all the small icons. And now we see the slides. Yeah, fine.
Yes.
Thank you.
Yeah. Great. Yes. I'm Tom Lehman. I'm from ESNET, and I'm going to talk a little bit about the SENSE project. And as you can see there, the focus on SENSE's orchestration, visualization, and workflow services. And it started off as a research project, but now with a fairly large team, but now it's gone beyond that. So the way I kind of describe SENSE is that we're really looking to fill in some gaps. And the gaps we're talking about are the gaps between domain science workflows and all this software defined, just they generically call it software defined layer that's underneath it. And so we've heard a lot about the many things that are going on with automating various infrastructures. So what we're trying to think about in SENSE is, what does it mean to make this end-to-end software defined infrastructure available and accessible to domain science workflows? And we're really focused on where we describe it as end-to-end networking, but we go a little bit beyond just the networking elements. We're also, when we say end-to-end networking in this context, we're including the networking stacks inside the end systems themselves. And today that focus is primarily on DTNs, but there's going to be other types of things that are attached to the network in the future that we also want to do. So if I think about this, you know, we heard about the TMF digital architecture earlier. Perhaps this is at that higher level with, you know, the kind of the customer focused level, but you know, maybe it's even beyond that because we're really focused on multi-domain and multi-resource. So I'm not sure if it fits completely neatly into that TMF digital architecture that we saw earlier. So as I mentioned, we're really focused on what does it mean for domain science application workflows to get access to this infrastructure and the services. So obviously, if we talk about filling in the gaps and SENSE is sitting there in the middle, we have a big focus on how can domain science workflows interact with this distributed network infrastructure. So we have a lot of features in SENSE, which are basically designed to allow interaction and negotiation effectively. And obviously, we're going to be limited by what the underlying infrastructures can do, what the underlying automations can do. So when we put SENSE just directly on top of ESNET, for instance, we have a lot of features that we have access to, scheduling and different types of network services. So there's a lot of types of interactions we can provide back to the domain science workflows. We can, you know, allow questions to be asked about, you know, things that might be planned. So when we have a domain science workflow that maybe is trying to schedule compute and they also need to move data as part of that, there can be kind of a co-planning activity that goes on with that. And we try basically to leverage whatever is underneath, you know, at the software defined layer. So, you know, there's a lot of different types of infrastructures that are being built, a lot of different automation. Fortunately, everybody is generally producing APIs now. So, you know, that's the kind of thing we absorb is what we can get available through an API access. And we try not to, on the Sense project, we're not really focused on actually developing resource controllers, although sometimes we have to. For instance, because we are trying to include the network stack inside the end systems, there are really no controllers for that. So we have actually built controllers which actually sit on top of DTNs and take care of the networking stack on DTNs, and it allows us to synchronize that type of provisioning with everything else that's going on with the network on the end-to-end path. So we have an architecture that is basically designed, as I mentioned, to just kind of leverage what is available underneath. And then if there's something that was not under control in the underlying infrastructure, then we build a controller for the DTNs. But kind of the key parts of the architecture is that Sense basically is a model-driven infrastructure. So it grabs topology information from the underlying infrastructure. It puts that into a model framework, builds globally or a total view of a connected network graph. And that allows us to reason about end-to-end infrastructure. And it was really tuned to NSI types of infrastructures because they leverage the same modeling language as the network markup language. And we leverage the same modeling language that the NSI standardized on, which came out of an OGF working group. But we can also absorb other types of infrastructures, like we do interact with other APIs that do not have any type of model-based description, and we have to do the conversion. So it's designed to basically kind of work with what's underneath it. But if we run into an infrastructure that already has a nice model-based description of their infrastructure, it just makes it easier for us to absorb.
1 minute.
Okay, and so just as an example, we have been focusing on the kind of the end systems of DTN. So how this really shows up in reality is that we have some capability that we can add to the DTNs, and then everything else can be the same in terms of you can use the best effort IP pass to use data, whether you're using some type of third-party data movement system. But there also be some priority services on there that allow the DTN data movement protocols to access maybe some advanced services that are provisioned on an end-to-end basis. And we also are working on, there's a larger effort known as super facility, where we're getting a lot of APIs now for compute facilities. So we want to make sure we have an API for the distributed networked infrastructure as well, so that the higher level workflows can also include the networking end-to-end and their co-scheduling and their planning process. And there's a long paper here that's available that has a lot more details on the Sense system. And if people read that and have any questions, please just feel free to send me any questions about that. And that's all I have.
Thank you very much, Tom. And thanks to all the speakers. And as you know, we were keeping the questions and answers for the end of the session. Are there any questions for our speakers that you would like to ask? I don't see any hands raising. I imagine all the speakers were so clear in their explanations that everything is super clear and you don't need any clarifications. Okay, so if there are no questions, I would like to go directly to the open discussion. Well, there is a question now from Tim. Is there opportunity for between Sense and SPA for GCS, both use OpenNSA interoperability?
Yeah, I can answer that. So Sense and OpenNSA, we do have an effort ongoing now with in the GNAG, there's an AutoGoal Sense working group. So basically Sense and AutoGoal work together, and AutoGoal is utilizing NSI in particular. So different people implement NSI different ways. So that includes collaboration with GÉANT and SURF and ESNET and a lot of other network providers. So we can basically integrate kind of the Sense services with what's available through AutoGoal and NSI.
Yeah, I agree. If it's NSI protocol, so no problem to integrate.
Yeah, I wrote a Sense RM that converts between the Sense protocol and the NSI protocol, and it runs on, I think it's on 8 or 9 OpenNSA instances right now. So if you guys have an OpenNSA instance you want it for, we can configure it and get the adaptation going.
Thank you. Does it answer the question, Tim? Well, I imagine it does. Thank you. And the next, if there are no more questions, would be to know what would be the next steps for us to take. We have been working on terminology, on architecture. We are mapping the NRENs to this functional architecture. Remember, it's a functional high-level architecture that can fit many different architectures on it, because it's just what you do inside your home is your own business. It's the biggest rule. And we have work on the training, we have a wiki and several white papers published. Is there anything that you miss or that you think that the GÉANT project should do as a next step for automation, orchestration, and virtualization in the community? Are there any ideas, any out-of-the-box ideas? Inside-the-box ideas.
Okay, if I may, what I like, I also work in Vertex, Work Package 6, but what I'm missing is some kind of commercial for this academy lectures and all the materials, the learning lessons. So if I'm not in Work Package 6, I would never know it. So maybe we should work on it more.
The promotion.
Because I know I would send it to all of my engineers to go through it. Yeah.
Okay, well, that's we're working on it. We have the video that Work Package 2 has created, and we're working on the newsletters. But it's true that we like reach the NRENs maybe, but we don't reach sometimes the end institutions, and each one of the NRENs is able to reach their institutions to promote this. So this is also one way to achieve this, or we're trying to push it not just to the NREN, but also to the end institutions if we can. And that would be one way. If the NRENs can do that or can spread the word about automation, about this material that you have ready for you in the wiki or in the academy. And let's see. Mauro, I see two ways of developing OAV, or put another way, what common things can we work on? Oops, no. Mauro say, I see two ways of developing OAV. One from technology, the other from data. Any comment on this? Okay. So Mauro, you mean that we can work on technology and also on...
Yeah, no, I try
Yes.
to explain my question. My question is that I've seen a lot of technology-driven automation and orchestration developments, but in some way those are for single area, then you merge together, then you get the big picture, but it's mostly around the technology you want to have and the services you want to have. What I liked in the ESNET presentation was that they started from the data of the database. In the sense they started to implement in the database the entities they want to operate in, and then they developed the technology to have the functions that does what they want in the intent-based. For me, that's a profound difference. It's not correct, but one is top-down, the other is bottom-up. And I would like to have a comment on this because we are also developing OAV. And I think we may have more issues if we start developing and merging together different OAVs or orchestrators and then having a full system rather than trying to understand the data, which are not many in the differences between them. Of course, there are a lot of data, but there are not many. And then develop on top of the data the functions you want to create. Having a common language on the data, having the more possibility also to interoperate, because you're really interested in the data and the analysis of the data rather than specific technology. Bridges are very simple. If you mean a different thing for a line, then you're in trouble from day one. So this was the reasoning behind this question. Thanks for any comment.
So if I could just add to that, so ESNet was very CLI driven. Configuration was done in YAML files, and ESDB was not being kept up to date. So ESDB would have an intended representation that didn't actually match what was in the network. For some of the service, some of the stuff absolutely 100%. Our IP services was very stringent about that. You know, we've switched to this model where you have to have the planned data in ESDB before you can kick off a workflow. It's really hard for the network engineers to switch to that model because they have to have planned and understand what they're going to do And it's just a different way of thinking, as opposed to getting on the switch and then figuring out what they need to configure or do some tries and then get the right config and then go make the config in the central location and then push it down. They've actually got to do the upfront planning and move from that perspective. We may end up going for more of a hybrid later on, but right now we're going to see how much they hate us after forcing them to use this model. Maybe it'll work, maybe it won't work. We'll have to see.
I'll say one other side effect of that model John's talking about from ESNET's perspective is that planning data in ESDB and the rigidity of our current orchestration is that the data we supply the NOC can't be wrong. So that's been both an unintended side effect of, it's nice to have that the outage information the NOC has is always correct because it can't be wrong because it can't be provisioned otherwise. But it does lose that flexibility that John's talking about, where previously that would be something that we do after you provision that you update the NOC's data.
We have a question. Yeah.
Because in the GAR environment, of course, the database is growing and is more and more difficult to keep up to date. More services, more connections, and it's not just a database. It's not a static thing. Actually, you provision something that is on top of other things and is on top of other things, and so the metadata and missing links are more and more complex to get in. And I think that was the main challenge actually of automating, because you have to operate on the right data. So thanks, I fully agree.
Thank you. There is a question from Niall Donaghy. It's, has anyone got data which quantifies the time pain saved from moving from manual methods to greater automation? I don't know if Wouter, as you have done this migration from SAFnet 7 to SAFnet 8, do you have any data of how much you have saved or how much pain or time you have saved?
No, I can't quantify it, but the success rate was very high of our migration. And that was something we didn't have in the previous network. So beforehand, we have imported all the existing services of ServNet 7 in the database, run all the validation checks. So we were sure that everything was 100% sure before we could start doing the migration. And the migration was flawless. So that's yeah. So I can't quantify it, but I can assure you that it's a big cost saving, because the engineers, the installation engineers are on site. You don't want to send them back home with a failed migration, because then you have to plan it again a week or two later, etc. It's very annoying for our customers, because typically you do that in outside office hours. So that's I think really crucial. Yeah.
Mm-hmm. Thank you.
Absolutely. Thank you.
Yes, well, the fact is that in the past it was very, very typical to say that the network was the inventory, and you didn't have the database updated, but you went to the network and you saw there how it was. And I think this is just exactly what we have to avoid if we want to go to an automated world. We have to have a source of truth and stick to that one, and not change things randomly in the network. That's probably something that was very common in the past. Are there any other questions or suggestions for improvement or suggestions for future work from you? I hope I didn't skip any messages, because I see many of them. But anyway, as we are about to finish this session, that was very useful, and thanks to all the speakers for all the presentations that were really, really good. I would like to encourage you to have more discussions. There is an automation channel in Slack in the NREN channel, where we can just discuss about any future ideas you may have about automation or any future topics for work. I think it's good to have collaboration. And of course, if any of you would like to participate in the training sessions or or be a teacher or a professor for these training builds, it would be great to have you on board. We will be more than happy. I know that probably here you are the ones that don't need training because you already know about this, But there are other NRENs that don't have this lack. They are not this lucky, and they may benefit from your knowledge. So I encourage you to do so. And with that, we'll post a link to the talks to automation, to the automation channel. If you're not there, you can register there. And with that, I would like to thank you all for being here again on a Friday afternoon and after all the TNC week. And you can reach us in oab@list.geant.org. And if there is anything else from your side, we will be happy to hear it. Anything that you would like to add? Okay, if not, thank you very much, everybody, and we can close this session here. Thank you. Bye.